Okay, so our project is called the Ferrous Wheel, Ferrous. Our concept came from thinking about drawing, if we could turn drawing into a way to play an instrument, and then the idea of the Woolly Willy game with the iron fillings came up, and so then we took the idea of the circle of fifths as a way to arrange notes on something and have iron fillings and draw images or just drag magnets around in a more, or the fillings around in a more abstract sort of way to play music or samples.
Yep, so we're going to run you through the construction of the device and then the sensors and the wiring arrangement, and then we'll talk about how that data is processed and fed into a synthesizer, which, as Jordan just mentioned, contains either chords, notes, or samples that produce music.
It is constructed from concentric rings. It's MDF, medium density fiberboard, stacked on top of each other. And the iron filings are contained within an acrylic case up here. And they can be moved around with these magnetic wands that were 3D printed. The inner case was made from acrylic to hold the filings, and the sensor plate that you can see below it, it was laser cut wood. And then the outside was made on an X-Carve CNC router.
Yes. So we can take off the shield for the wiring. And as you can see inside, we have a arrangement of wires that are on little PCB circuits that contain multiplexers. So the thing that was very important with this project was that we wanted analog sensor data, and in order to collect that, we did not have enough analog pins on our Arduinos that we were using. We're using the Arduino Mega, and therefore we needed to have multiplexers that were able to collect more than, I believe it's 19 pins on the Arduino Mega, and that allows us to collect more data and instead of just having digital on-off signals, which gives us a little bit more flexibility in terms of the velocity in which the magnet filings create for the MIDI notes. And again, the Arduino Mega is contained inside of the device, and the device holds 25 photoresistor sensors that are calibrated at, I believe they're 10 kilo ohm at their max, and that allows the device to detect motion. So for example, I can even use my hand. Obviously the fun part is drawing, but as long as I put my hand over it, it detects that there's a change in light, and that'll trigger the sensors. There, of course, I triggered all sensors, but if I drag over a specific sensor, we can try the camera. If I drag over a specific sensor, it will trigger. Now we can go around the circle. And now we'll look at the Arduino code here. So as you can see, we're looking at the serial monitor. And if I use my hand and cover the sensor, you'll see that there is a significant change in data. That again. So now we'll look at the Arduino code, and as you can see, we have our serial monitor that's plotting or reporting all of the sensor data. This includes a intensity value for 2 to the 10 different possibilities. That's the amount of definition that the Arduino Mega supports. And then if I put my hand over it to cover the sensors, you'll see that there is some variation. It's probably very difficult to capture it on camera, but you can see that there is a change in the serial output. So it's reading each sensor and it's reporting the different intensity values and also reporting if the note is currently on or off, and that allows us to do some simple work in Max to ensure that the notes are played at the right time and also turn off correctly. So we can go over to the Max patch now. So this component up here in the max patch is responsible for collecting all of the data from the Arduino, from the serial output. So this uses serial communication between the Arduino and Max to ensure that all of the data is received and able to be translated into music. So if I turn this on now, you can see that all of these little blocks in this unpack object represent those values that we saw in the serial monitor. And if I cover them up, they change, and that generates note data through these lower blocks here. Try to focus in on one. Focus a little harder. There we go. So we take in the intensity value and we scale it to 0 to 127 because we're following the MIDI specification. And then we also have this value that we assign in Arduino code, and that determines if the note is on or off, and that allows us to, if we detect a change in that bit, then we can send a bang that sends the pitch, allowing us to create a note that is played, and all of these notes go out to the same channel in Reason, which is the synthesizer that we are using. And there's also functionality. We decided that we did not want any other buttons or devices on the product for this implementation. So any channel changing is done using a interactive box within Max. Up here we're allowed to change the sounds. So this is a chord sound. I can grab one of the
Okay, so this is the Reason patch. I did all the work within an N19 and just assigned, recorded my own sounds into it. So it says it's a Farfisa organ, but the sounds aren't the Farfisa organ sound. So, like we said, we wanted it to be based off of the circle of fifths, which goes C, G, D, A, etc. Around the outside, and then the parallel minors, so starting on A minor, around the inside. So theoretically, that should sound better than having all of the notes just go consecutively in order, because if you like dragged it across, then that would get much more muddled faster, although it's obviously still not perfect in terms of not getting muddled. So I recorded through subtractors, but they are deleted now, directly into the N19. So this is 2 octaves, which we have 24 different note assigned photoresistors. So this uses every note or chord present in the circle of fifths. So this from C0 to C2 is assigned all of the chords that are in the circle of fifths, and from C3 to C5 is just the single note that starts all the chords in the circle of fifths. And then from C6 to C8 is a sampler mode, so there's some nature soundscape sounds, there's a lot of chiptune-y sounds, there's some more musical, longer held out sounds that you could play other sounds on top of, and then there's also an assortment of an octave of notes, so you could have the soundscapey part of it and play single notes on top for more musical variability.
We can do a playing
Did
demo.
everything? Yeah, we can do a playing demo. And Joe already showed how we go to each of these 3. So they're all within one N19 because there's only so many channels that you could assign to in Reason from Max, and it would not have worked to have 36 of double 36 of them. So it's just all within one N19, so it's only 24 over and over again.
I'm going to demonstrate note mode. Control of the instrument is very straightforward. There are a set of wands that each have different size magnets in them, and then each of the pair of the same size magnets have different polarity, so they will repel each other, which allows the user to have fun with the electric fields, the magnetic fields. And then some of the wands will repel each other, some of them will attract a little more. It's all fun. whatever patterns you want to create as you're going. Or you can go for individual notes. Because they are photoresistors and light sensitive, it's important to be aware of how much your arm is covering as you play, if you want it to really just be controlled by the magnet. Pretty intuitive, and I made a cat.
Okay, so this is the sampler mode, which should be sounds on the outside and notes on the inner ring. Let's see. Leave that. Just messing around. Okay. That was very naturey, spooky. Kind of sounds like a museum exhibit.
We also have chord mode. It's clear at this point that there's a lot of precision required to be very virtuosic with this instrument, but that's what makes instruments fun to play, is the challenge of them. We feel that our instrument has a very interesting learning curve. There's a lot of dissonance and chord bleed. My attempt to draw a star. We can't all be winners.
It's a performative process.
So there are some future considerations that we could make if we decide to continue working on this project, and that would improve user experience and functionality. And one of those is adding a mode changing switch.
It makes sense for the user to be able to change between modes from the instrument itself with some sort of button or switch, as well as having some sort of volume control without needing to go into the software.
Yeah, so we have 24 sensors in an outer ring and an inner ring according to the circle of fifths, but because there's also space in the middle, we added a 25th, and it does physically exist on this version of the instrument, but in the future that could be implemented to control volume or timbre or some parameter. So
But overall, we feel that we've made a very interesting instrument and synthesizer controller that we feel that we have not seen much of in terms of drawing MIDI applications. There are obviously many other ways to implement this, but we found the magnet concept very interesting, and we rolled with it, and it's very exciting. So we're glad to showcase it to you today. Thank you.